This is our submission for CSE316 Embedded Systems Lab. I'm Sameed here with my partner Salman, and we are going to present our project, which is rotating LED display with wireless control. First, I'll go over what this project actually does, and then I will explain how it does it. So when I connect it to power, it starts spinning, and at the moment it's showing the time 4:24:18 seconds. And there are a few different modes. For example, if I switch modes, it's now in mode 1, and what this mode does is displays a random string that we can send over Bluetooth. For example, random, or another word like hello. So there's also a third mode, which is an analog clock. And with this edge being 12, it's showing the time now, that is 20 minutes and some seconds. Now I'll go over the hardware in some more detail, the names of the components we're using, and the circuit diagram will be found in a GitHub repo I've linked down below. The main component we're using is the Arduino Nano. It's connected to a Bluetooth module and an RTC module. Here there are 12 LEDs, green and 12 yellow. These are multiplexed, so at any one time, either the green or the yellow can be on. That too can be switched using Bluetooth. On the back we have a proximity sensor that senses if something comes in front of it. Whenever this proximity sensor fires, it calls an interrupt function in the Arduino, and that actually starts displaying the text we want it to. I've used a toy wheel for mounting, and there's a battery. It's a standard 3.7 lithium-ion battery with a charging circuit, so it can be charged. And using this lithium-ion battery, we're powering these three modules over here. Along with this, we have a wooden mount with a motor on it, like so. This motor actually connects to a USB cable like this, and we can power this using any old charger. Importantly, this motor does not connect mainly to this board because since it's spinning, there wouldn't be a way to communicate between the two. So what this main circuit does is whenever it detects an interrupt, it can keep count of the time using the RTC module and actually calculate the RPM that the motor is spinning at. So in this way, the main module doesn't really need to communicate with the motor directly. It can simply calculate whatever RPM the main motor is spinning with. We've went over the problems and solutions in greater detail in the report, which can also be found in the GitHub repo. I'll not go over this in this video, but the report should help if anybody wants to build this for themselves. Thank you for watching.